Right, now we can continue this problem. So we discussed the fundamentals of factor theorem. Basically, for this case, x minus 1 is a factor. So which means x minus 1 will be inside that function, right? X minus 1 times something. And more importantly, what we discussed, x minus 1, if x minus 1 equals to 0, then y equals to 0, like that. So this is the factor theorem here. If x minus 1 is a factor, then f of 1 equals to 0. In other words, in simple words, if x minus 1 is a factor of f of x, then x equals 1 is a x-intercept for this function, right? Then x equals 1 is a x-intercept, right? Basically, this part you can set this equals to 0. That's the idea. So you can write that straight away. If x minus 1 is a factor of f, what's the meaning of that? F of 1 equals to 0, right? That's what we discussed actually. If x minus 1 is a factor of f of x, then f of 1 equals to 0. Basically, f of 1 means y value when x equals to 1. Y value when x equals to 1 equals to 0. In other words, the same thing actually. Y value equals to 0 means at that point the height equals to 0. When x equals to 1, the height equals to 0. Which means they're expecting something like no height at that point. The height equals to 0. So that's the idea. Then, so we want to compute k, determine the value of k. So here we have f of x. Let's compute f of 1 because we know that f of 1 equals to 0. From that, we can build one equation. So that's the idea. To compute one unknown, we need one equation. That's what I am going to build here, right? So this is what I'm going to use. Now we know that f of x equals to this one, but we know that f of 1 equals to 0. So let me replace each x by 1. Worth putting a bracket like this. K times 1 squared plus 1 minus 6. Simplify each part. 1 plus k times 1, that is k, plus 1 minus 6. 1 plus 1, 2, minus 6, minus 4. So k minus 4. That is f of 1. But since x minus 1 is a factor of f of x, right? We do have this information. Otherwise, we can't solve this. We know that x minus 1 is a factor of f of x. Therefore, which implies f of 1 equals to 0. Hence, we do have this value actually. That is 0. here, that height. Here at this point, the height, there is a height. But when x equals to 1, the height equals to 0. That's the function value. The height, always the height. So k minus 4. Then move that 4 to the other side. So k equals to 4. That's the answer. Now you can express that function without k, this function. F of x equals to x to the power of 3 plus, I'm going to replace that k by 4, this k, 4x squared plus x minus 6. That's the function, right? So that's how we solve these questions. Always remember, you can go both ways. For example, if you can find a value, for example, let's say 2, just a random value, f of 2, let's suppose if f of 2 equals to 0, then we can write that x minus 2 is a factor of f of x. But in this case, I don't know that, right? But probably, yeah, x equals to won't work. But in this case, f1 equals to 0. What's the meaning of that? If f of 1 equals to 0, then x minus 1 is a factor of f of x. Also, the other direction is correct. If x minus 1 is a factor of f of x, then f of 1 equals to 0. That's why I mentioned previously, you can go both ways. In this problem, particularly, we followed this path because we had that information. That is, x minus 1 is a factor of f of x. Right? For some problems, you might have to follow the other direction. Okay. Right, let's try another problem. Same idea. Right? Determine the value of k and m. Right? We can try this question.